Hey, ladies and gentlemen, today we'll look at arc length, how to calculate the arc length in Math 6. So the question says calculate the length of the curve 2y squared equal to 3 equal to x cubed between x equal to 0 and x equal to 3. So once I read the question of arc length, what is important to me are the limit, because the guide me to know which formula do I pick from page 7 of my formula sheet, because the formulas for arc length are on page number 7. So if your limits are in terms of x, as you see here, it therefore tells you that the formula you are using must be in terms of x. So as an N6 student, there are 3 formulas on page 7 that start with s equal to. Those are formulas for arc length. So the one we are picking will be the one that will end with dx, because the limit are saying so. So this is our formula, dy over dx, or the square, then dx. So that's the right formula. So once I've picked the right formula, which I'm informed by the limit, then that formula guides me through every single step. So I'm going to get dy dx, as the formula says, square it, then add 1 to it before I come back to the square root sign and do integration. So let's now look at the problem. We've got 2y squared is equal to x cubed. So the way the problem has been presented to me, you see y is not the subject. So if I want to look for dy dx, there are 2 options. One was done in N5 maths, where you can do implicit differentiation there before you make dy dx the subject. And the other one, you make y the subject first before you differentiate. So I'm going to try to go through both. So let me start with implicit differentiation. So when I differentiate this side, it will give me 4y dy dx. With implicit differentiation, each time you differentiate y, you will get dy dx. Then if I differentiate this side, I will get 3x squared. Then I will make dy dx the subject, which means I divide both sides by 4y. That will give me 3x squared over 4y. Then I'll just go on and square it, because I've got my dy dx already. I'll go on and square it as the formula requires. So if I square that, I'll get dy over dx, all that squared. That will be telling me that I have 3x squared over 4y, all this squared. And if you square this, the square of 3 is 9. Then you get x to the power 4 divided by 16 y squared. And now you must remember that since your formula ends with dx, that is reminding you that when you come to the stage of integration, y must not appear in here. So this is that stage where you can take care of the y. So after squaring, you realize that this y squared can be taken care of from the original equation. So if I go back to the original equation, you see that your y squared is equal to x cubed over 2. So that is what I will put there. So if I put it in its position there, I'll get 9x, x to the power 4 divided by 16 in the place of y squared. I'm putting what? X cubed over 2. So this should simplify to, you see that x to the power 4 divided by x cubed will simplify that to x. Then 16 over 2 will give me 8. So what I'm left with is simply 9 over 8x, which can be managed in our integration, because our integration is very specific that I need only x when I want to integrate. So that is option 2 of getting dy dx, all that square. So that is option 1. Let's go to option 2. Option 2 says if I get 2y squared equal to x cubed, I must start by making y the subject. So I'll make y squared the subject first to get x cubed over 2. Then y becomes the square root of x cubed over 2. And that means x to the power 3 over 2 divided by root 2. Since the square root can go over the division sign. So that is how I must arrange my problem to look like before I do my differentiation. So if I do my differentiation, dy over dx will give me, you see, I will not be differentiating the denominator because there is no x there. I will only differentiate the numerator. Then I divide by root 2. If I differentiate there, I will get 3 over 2 x to the power a half, which is the same thing as 3 over 2, then root of x divided by the root of 2. So that is what I get. Then if I go on and square both sides, since I need dy dx all that square, it means I'm squaring 3 over 2 root x on root 2. That's what I'm squaring. If I square the numerator, I'll get 9 over 4x. Since the square will take out the square root, then all this divided by 2. And you see it, if you check now, 9 over 4 divided by 2, it still takes us to 9 over 8x. Yeah, so that is what you get. So you see, whichever method you use for your derivative, you end up with 9 over 8x. So it's now left for you to decide whether, once I get this problem, do I differentiate implicitly or do I make y the subject first before I differentiate. So at this stage, I can now go back to my formula. I'm done with this portion of the derivative, the first derivative, all that square. So if I now go inside the square root, I get 1 plus that square of the first derivative, which simply gives me 1 plus 9 over 8x, which looking at it, can't be simplified further. So that means I can go straight to my integration. So s is equal to the integral from a to b. Your a will be the lower limit, your b will be the upper limit. So it's the integral from 0 to 3, the square root of 1 plus 9 over 8x dx. So this is what we call integration by substitution, because when you say let u be equal to what's under the square root, you differentiate it, it will give you 1. So for N6 student, the fastest way of doing substitution is using what we call the power rule. The power rule, it's on page 4 of your formula sheet, which says if you are integrating f of x, all this to the power n, you multiply it by its derivative, which gives you f of x to the power n plus 1 divided by n plus 1 plus c. So that's the power rule. So for those who want to work fast, all they need is to arrange the problem to look like the left side of the power rule, then they use the right side to get their answer. But if you prefer to say let u be 1 plus 9 over 8x, you will still get to the right result. So I prefer to take you through the power rule. So the power rule, that square root is b, it's now our n, because that's the power. So I get 1 on 9 over 8x. Its power is 1 over 2, so it means I've captured that portion of the power rule. Then I have to multiply by the derivative of what is my f. You see your f is there. If you differentiate this, the derivative of 1 is 0, then here you differentiate, you get 9 over 8, then you have dx. But now to be sure that the power rule is complete, you must compare what you've written here to the original problem. If you compare the two, you will see that 1 plus 9 over 8x appears. The square root is in the place of the half, but 9 over 8 does not appear in the original. So in order to balance it up so that the two problems are the same, you must look for what can cancel this 9 over 8. You keep it out, which is obviously 8 over 9. So in that way, if you use the power rule to do your u substitution in one simple step, then it's time to write our answer. So to write our answer, you start with what is out of the integral sign. Then in there, what you do is now you use the right hand side to write your answer. And all you do is whatever was in the place of f of x on the left will also go to that place on the right. And that was 1 plus 9 over 8x, all this to the power 3 over 2 divided by 3 over 2. 3 over 2 because that power has to increase, as you see. From n, we have to go to n plus 1. So that is it from 0 to 3. Then now we substitute our limit, starting from the upper limit. If you put the upper limit there, if you put 3 there, you have 9 times 3 is 27 over 8. Then you need to take 27 over 8 plus 1. If you're not sure about it, you can use your calculator. 27 over 8 plus 1 gives me 35 over 8. So I'm having 35 on 8 to the power 3 over 2 divided by 3 over 2. So that is what happens once I put x, I replace x by 3. Then I go to the lower limit, I repeat the same process again. I replace my x by 0. If you replace by 0, all of this is 0. only left with 1, and 1 to any exponent is 1 divided by 3 over 2. So it's now left for the calculator to complete the job for us. So we'll use the calculator to do that calculation. So for me, what I'm seeing is that 8 over 9 is a common factor. So I'll just capture this minus this. Then whatever answer I get, multiply by 8 over 9. So I've got 35 on 8. That's what I've got. I'm raising you to the power 3 over 2 is 1.5. Then I divide that by 1.5. That is what I see. Capture that part, then minus 1 over 3 over 2 is the same thing as 2 on 3. So that is my answer. Then I multiply by 8 on 9. So that gives me 4,832. So I've got 4,8302 unit as my surface area. So guys, that is how you calculate the arc length. So I'm calling the surface area is the arc length. That's how you calculate the arc length in Maths 6. Thank you very much.